Lecture 1.4, Parametric Equations. The photo is the Mount Washington Cog Railway in New Hampshire. This engine was over 100 years old. Most of the steam engines have been replaced by more modern engines recently, which run on biodiesel. The photo is by Greg Kelly, taken in 2005. There are times when we need to describe a motion or a curve that is not a function. We can do this by writing equations for the x and y coordinates in terms of a third variable, usually t or theta. We would have x equals f of t and y equals g of t, for example. These are called parametric equations. T is the parameter. It is also the independent variable. Example, x equals the square root of t, y equals t, where t is greater than or equal to 0. To graph on the TI-89, we press Mode, Graph, and we select 2 Parametric, and press Enter. Then diamond y equals, we enter the equation for x of t, and those are the keys to use. Then we enter the equation for y of t. Press diamond window to set our window. In this case, we want t to go from 0 to 10, t step to be 0.1, that's how much t changes before you plot the next point. In the viewing window, we want x to go from -5 to 5, and y to go from -5 to 10. We then press diamond graph. And there's our graph. If we hit zoom square, there's our zoom command right there, F2, we can see the correct undistorted curve. We recognize that as half a parabola. We can confirm this algebraically by starting with x equals radical t and y equals t, and we substitute in the value for t, which gives us x equals radical y. Squaring both sides gives us x squared equals y, where x is greater than or equal to 0, or y equals x squared, where x is greater than or equal to 0. We recognize this, of course, as a parabolic function. For a circle, if we let t be the angle, then we can draw a triangle, and x is equal to the cosine of t, y is equal to the sine of t, where t goes from 0 to 2 pi. Since sine squared plus cosine squared equals 1, we have y squared plus x squared equals 1, or x squared plus y squared equals 1. And we could identify the parametric equations as a circle. graph in your calculator. Diamond y equals xt1 equals cosine t, yt1 equals sine t. Use a -4 to 4 by -2 to 2 window. And we press diamond window. We're going to let t go from 0 to 2 pi. And we don't have to enter the decimal. We could just enter 2 pi and the calculator will change it to a decimal. Then we enter the other values and press diamond graph to get our circle. Now let's graph an ellipse. The equations we'll use are x equals 3 cosine t and y equals 4 sine t. As you can see, these are just the circle equations that have been stretched in the x and y directions. If we solve for cosine t and sine t, then we can use the Pythagorean identity to rewrite this equation as x over 3 squared plus y over 4 squared equals 1. And we recognize this as the equation of an ellipse. Converting between parametric and Cartesian equations. We have seen two techniques for converting from parametric to Cartesian. The first method is called eliminating the parameter. It requires solving one equation for t and substituting into the other equation to eliminate t. This is possible when the graph is a function. The second method used the Pythagorean identity to eliminate t by using the fact that sine squared t plus cosine squared t equals 1. Both of these methods only work sometimes. There are many curves that can only be described parametrically. On the other hand, changing from the Cartesian equation for a function to a parametric equation always works, and it is easy. The steps are: 1. Replace x with t in the original equation. 2. Let x equal t. For example, y equals 2x cubed minus 5x plus 4. To change that to a parametric equation, it becomes y equals 2t cubed minus 5t plus 4, and x equals t. In the special case where we want the parametrization for a line segment between 2 points, we could find the Cartesian equation first and then convert it to parametric, but there is an easier way. We will use an example to illustrate. Find a parametrization for the line segment with endpoints -2, 1 and 3, 5. Using the first point, start with x equals -2 plus at and y equals 1 plus bt. Notice that when t equals 0, you get the point -2, 1. This term here cancels out, so we get x equals -2, and this term cancels out, so you get y equals 1. Substitute 3, 5, and t equals 1. We have 3 equals -2 plus a times 1, or 5 equals a, and 5 equals 1 plus b times 1, or 4 equals b. The equations become x equals -2 plus 5t, y equals 1 plus 4t, and t goes from 0 to 1.